Today's class is depreciation. Now, I was away when you learned about the first method. So what I want to start with is a plain English definition for depreciation. If I use this word, what am I talking about? Yeah, so if I buy something, it doesn't always grow in value. It means the reduction. Yeah. So reducing, reduction, losing, all of these words capture the idea of depreciation. The best example of this is buying a car. So unless you buy a car that's going to become a classic car that everyone wants in 30 years' time, the moment you buy a car, you cannot sell it at the price you got it for. It'll lose value. Okay. When I was away, we modeled depreciation using an arithmetic sequence. Today, we are using a geometric sequence. So here's our common ratio, capital R again. And this time, if R, lowercase r, is the annual, so that means yearly, depreciation rate, we are going to define capital R equals 1 minus lowercase r over 100. So much like simple interest, where we recalculated the amount of interest every time period, same idea with reducing balance depreciation. So instead of reducing by the same amount each time, which was the flat rate method, reducing balance will recalculate the reduction every time. So I might just make a brief comment here. Flat rate, same depreciation each time. Reducing balance, we recalculate it. In yesterday's class, we divided R by P. There is no P value this time. We're just going to depreciate watts per year, so that's going to make this a lot simpler. Jet, Kaylee? No. So have a look at example 5 now. So what's happening here is I am buying a car for $25,000. I am depreciating it at a rate of 8% per year. Remember, annum means year. The third sentence is just to make it absolutely clear, once per year. And the first thing we want to do is set up a recurrence relation. So it's going to look like this. V naught equals A. Vn plus 1 equals R times Vn. And all I need to do is make appropriate choices for A and capital R, and I'm done. So any ideas for V naught? 25,000, that's how much we've got at the beginning. Now, what do we need to know to calculate capital R? I can't just use the number 8 in the recurrence relation here. Okay, and so that's lowercase r, which is 8. Thanks, Noah. So lowercase r equals 8. We were given that in the question. It's your job to identify that as relevant. And then capital R is 1 minus r divided by 100. And that's going to give me 0.92. 1 over 100 is 0.01. 8 over 100 is 0.08. 1 minus 0.08 is 0.92. So the next part of our recurrence relation will be Vn plus 1 equals 0.92 times Vn. Okay, part B. This is a question you can be asked next year. We want recursive calculations. So this means you need to use the recurrence relation. So I won't belabor the point because we've done this in an earlier class. V1, and now I'll use this equation here, is 0.92 times V0. But we know what V0 is. That's the initial value of the car, 25,000. And if you do this calculation, I believe you will get 23,000. Let's double check that. All right, Polly, I'm going to ask you, how can we get V2? Yep, that's it. So all we're doing here is we are moving forward in time by 1 year, and every time I go forward by 1 year, I'm multiplying the value by 0.92. Okay, Jai, I know you weren't here yesterday, but what do you reckon for V3? Sounds like a plan? All right, that's it. Okay, part C. There are a few questions like this in the textbook. They don't just ask you to calculate the value after a certain amount of time has passed. They ask about what's happening in a particular time period. So we've calculated 3 numbers: after 1 year, after 2 years, and after 3 years. Have a think. In the second year, how much value have I lost? 16%. It's actually not 16%. So we can do a calculation later to show that. I'll add a page for this and upload it later, or we can talk about it. This is actually something that's worth discussing later because you're going to be examined on percentages. So we'll come back to that. Part C is actually not asking for a percentage. We're asking for an amount in dollars and cents here. Okay, so it's actually simpler than that. Okay, and how did you, what calculation did you do, Sean, to get that? Okay. Is that it? Yep. Okay. Now, how do we know that this is the amount lost in the second year? And this is correct. But you will all need to reconstruct this on your own soon, like next Tuesday. So you're being tested on this topic. So I agree with this, but how do we know that this is the amount lost in the second year? Yeah, that's right. Okay, so we've got 25,000 at the start, 23,000 at the end of year one, 21,160 at the end of year two. So these are the two numbers we want to use. And so symbolically, I can write this as V1 minus V2. So for the amount lost in the third year, I would do V2 minus V3, etc. Okay, two more examples and then a brief detour on percentages. So please turn the page to example 6. If you haven't written everything, the notes will be on Teams, so don't stress. I'll upload them once the class is over. Okay, so this time we are told we've bought a van for $50,000. It's the reducing balance depreciation method. This time the rate is a bit larger. It's 15%, so we're losing a lot more money each year. And it's once per year. That's just a technicality to make sure there's no ambiguity. Part A, set up a recurrence relation. So I think I'll just do it this time. The annual depreciation rate, lowercase r, is 15. Capital R is 1 minus r over 100, and that gives me 0.85. Remember that when we're dealing with a reducing balance depreciation question, we're using a geometric sequence. So it'll look like this. You just have to choose lowercase a and capital R. So in this case, our initial value has changed to 50,000. And Vn plus 1 this time is 0.85 times Vn. Exactly the same as the previous example, I've just changed some numbers. Okay. Doug, I'm going to ask you. Can you tell me a rule for Vn in terms of n? So got the recurrence relation here. Now I want the rule. Carl? Okay. Evan? This is my recurrence relation here. I want to turn this into a rule. Okay, great. This is a starting point. Orange is the recurrence relation. Green is the rule. If I have the rule, then I don't have to go forward in time until like a really large number. Thanks, Evan. Evan has given us the symbolic form with letters. In part A, we actually chose the numbers A and capital R, so we can do the same thing for the rule. Vn equals 50,000 times 0.85 to the power of n. All right, Kaylee, we've got the rule. Now I want to find the value of the van after 10 years. Do you have an idea how we might go about doing this? Sounds good. Because everything is yearly here, we don't have to worry about whether we're converting from years to months. So V10 will be 50,000 times 0.85 to the power of 10. And that's going to give us 9843.72. Okay, so if you lose 15% every year for 10 years, after 10 years, your $50,000 van is only worth about $10,000 now. And this is a matter of practical significance for anyone who's going into business. You spend all this time buying all your nice stuff, but then after 10 years, nobody wants it because it's depreciated in value. It's not worth the same amounts. So, part D. You'll need your CAS calculators for this, so grab them out if you have them. So just looking at the answer to part C, it looks like the answer might be n equals 10. Let's see. So think back to what we did yesterday. What's our approach here? What did we do yesterday with a question like this? Yeah, we don't want to use algebra here. We're not going to be able to do it, at least without. Yeah, menu, algebra, and solve. Yeah. Okay, so solve for n using the CAS. Anyone got a value yet? 9.93? Yep, sounds reasonable. 903? I'll screenshot something later. Yeah, this is really slow. So this calculation shows that 9 years is not enough, so we have to round up to 10 years. So just like yesterday, to meet a savings account goal, if we've got a decimal, you have to round up to the next time period. So while you're writing that, I'll screenshot this in. Oh, but you can't see it. Apologies. Won't be long. Okay, let's wrap things up. This is the last work example for Unit 1. This is the last bit of content. After today, you'll have time to revise for the test, and after the test, you'll have time to revise for the exam. Yes. Yes. Okay, so just like yesterday, we went from practical situation to recurrence relation. Now we're going the other way. We've got the recurrence relation. We want to reconstruct the practical situation. All right. Any ideas with this one?
We do 0.8 form in big R,
Yeah,
and then equals 1 minus R.
that's it. So we've got a situation where we don't know the annual depreciation rate. So I'll just write this so it's really clear for everyone. If I can solve this equation for lowercase r, I'm done. And there were two methods. We could use algebra or we could use the CAS. I will leave it up to you. Personally, I would hope that you can actually look at this and see what the solution is. R is 16. So why is that? Well, I know that 1 minus 0.84 is 0.16. And 0.16 is 16 on 100. And so there's actually no need to do any algebra if you can see that. If not, then deploy your algebra skills. So in this case, I will subtract 1 from both sides. And then multiply by negative 100 on both sides. Now, if you write r equals 16, that is okay. I won't deduct a mark, but a better answer would be the rate of depreciation is 16%. I think that's a better answer.
You want to ask to write 7.
I think this answer demonstrates more understanding than this answer. The question asks for a percentage, so I don't know if you mean 16 as a number or 16 as a percentage. Whereas here, it's very clear. I've given the percentage as my answer. I'll just give you a few moments to grab the rest, and then we'll quickly answer Noah's question, which is quite an insightful question. So it's worth spending just a few moments on that. Okay, what I want you to do is do 0.92 squared. Evaluate that for me. So if it's a 16% decrease, I should get 0.84, but you won't get 0.84.
0.846.
It's slightly more. So this is a 15.36% decrease. Okay. The reason why it's not 8 plus 8 equals 16 is because it's multiplication. So I recalculate the depreciation after the first time period. If it was flat rates, it would be, but because it's geometric and multiplication, it's not. Okay. All right. Congratulations on completing Unit 1, at least the class part. But you've got plenty of work to do. You can now have a go at the depreciation questions, which I've listed there. But of course, continue from where you have left off if you're not up to that yet. All right, thank you. You may have a quick go at some questions in the last 10 minutes.